Hello, primary 4 students, how are you? Welcome in your science class with me, Dr. Hamdy and your channel, the Big Sister channel. As now, we will study lessons 2 and 3 from Concept 3, Unit 2. Here we have lesson 2 from Concept 3, Unit 2. Please don't forget to subscribe, like, and share my channel. Here we have activity 4, basics of speed. What the meaning of the word speed? Yes, as you see here, this is tortoise. It's very slow, as you see here, as it can move a distance in a very long time. So we can say it has low speed. But here, as you see, the kangaroo moves quickly, as it can move a distance in a short time. We can say that it has high speed, okay? So the speed is a relationship between the distance and the time. It is a measurement of how fast something moves. How fast something moves. As we said, it is a relationship between distance and time. So we can define speed as it is the distance that an object travels in a certain time. So it is a distance that an object travels or moves in a certain time. This is the definition of speed. It is a measurement of how fast something moves, or it is a distance that an object travels in a certain time. Okay? So, what is the unit of the speed? Anything that we measure, it has unit. As if we measure a distance, we call this is 1 meter, this is half meter, or 50 centimeters. If we measure time, we say 1 hour, 2 hours, or by seconds, in 30 seconds or 10 seconds. So seconds and hour, kilometer, and centimeter, all of them are units. So the speed is a relationship between distance and time. So we can say here the unit of the speed has these two units: the unit of distance, which is kilometer or meter, and the unit of time, which is hour or second. Okay, so here we can say the equation of the speed if we want to calculate the speed, okay, of a moving object. It will be the distance divided by the time. So here the distance is by kilometer or meter, and the time is measured by hour or second. So the speed unit may be meter per second or kilometer per hour. Per mean this slash is called per, okay, as the speed is a distance per unit time, okay. So here we can refer to the speed by using the letter S, and for the distance we can use D, small d, as you see here, and the time we can refer to the time by the letter T. Okay, so here I want you to think with me. Does the speed of an object affected by its direction? As if this object moves right or left, well, this affect the speed, make the speed change? Of course, no. Only the speed depends on the distance and the time. Okay? How fast the object moves, the distance that moved by the object, and in how much time. Okay? And we have here example 2. Understand this part. If we have a car that moves 5 meters in 1 second, and it moves backward 5 meters in 1 second. So let us calculate the speed, as the speed equals the distance divided by the time. So here the distance is 5 and the time is 1. So here the speed will be 5 meter per second. And we get this unit from the problem, as we have here 5 meters. So the distance is measured by meters and the time is measured by seconds. So here the speed unit will be meters per second. Okay, and this is the first part. As we calculated that the car moves forward with speed 5 meters per second. Okay, now it moves backward, okay, in another direction. And the distance that this car moves 5 meters in 1 second. So if we calculate it, it will be 5 meters per second. So here the direction doesn't affect the speed, only the distance and the time. Okay, you get it? Here, if you are good at math, we will see now. Okay, here we have a problem. Amir runs 100 meters in 20 seconds. Calculate the speed of Amir. Here we have the distance 100 meters and the time is 20 seconds. When we divide the distance by the time, it will give us the speed. So 100 divided by 20 equals 5. Here, what is the unit? Yes, the distance is measured by meter and the time is measured by seconds. So the speed unit here is 5 meters per second. If you like to calculate the speed, so here is another one. If a bus traveled 600 kilometers in 6 hours, calculate the speed of the bus. So here S equals D divided by T, as S refers to the speed, D for the distance, and T for the time. Here the distance is 600 kilometers. So we will divide 600 by the time, which is 6. So 600 divided by 6, it will equal 100. And the unit here, can you tell me the unit? Yes, the distance is measured by kilometer and the time is measured by hours. So the speed unit here will be kilometer per hour, 100 kilometer per hour. Excellent. This if we measure the speed for one object that moves. If we have two objects, okay, and we want to compare between the speed of these two different objects, how can we do this? Yes, we have two things. As the speed depends on the distance and the time, so we can measure the distance that both objects travel at the same time, as we will adjust a timer, okay, as to make certain time, and we will measure the distance that the two objects move. The first way to compare the speed of two objects that move, okay, you can predict the second one now, the second method, as yes, to measure the time that both objects take to travel the same distance. So the distance, we have a certain distance and we will measure the time taken from the objects to reach this distance, okay, to finish this distance. Okay, we have examples here. We have here two runners and we will measure the distance that they move or run in 1 hour, okay? So we find that player number 1 runs 6 kilometers per hour in this hour, okay? And player 2 moves 9 kilometers per hour. So who is the winner? Yes, and the winner is runner number 2. And this is why, because he moves greater distance. So he moves greater speed, and a greater speed. He was running very quickly, okay, the faster. This is why we calculate the speed. The speed is the distance divided by the time. So here, the speed of the first runner will be 6 divided by 1, so it's 6 kilometers per hour. And the speed of the second runner is 9 divided by 1, so it's 9 kilometers per hour. Okay, so he moves more distance and he has the more speed. Okay, so here we can know that the object that travel greater distance in the same amount of the time is moving greater speed. Okay, now it's time to take an example for the second method to compare between the speed of two objects. Okay, as we have here a certain distance and we will measure the time taken from each object to reach this distance. As here we have two race cars, the red one and the blue one, and we have a certain distance which is 120 kilometers, and we will measure the time that taken by each object, by each racing car to move this distance. Okay, so we find that the blue race car moves this distance 120 kilometers in 1 hour, and the red race car moves this distance 120 kilometers in 2 hours. Okay, it takes more time to cut this distance, to move this distance. So here, which one has more speed? Yes, we will calculate them. As here, for the blue race car, the distance 120 kilometers divided by 1 hour, so the speed is 120 kilometers per hour. And for the second race car, the red race car, we have here the distance 120 kilometers divided by 2, so the speed here is 60 kilometers per hour. So we can conclude here that the object that travel the same distance in small amount of time, shorter time, okay, as the blue race car, it moves the distance in 1 hour, okay, has greater speed. Okay, now we will study activity 5, racing downhill. Here is a difference. We calculate and we know the speed in flat surface. Okay, now what happens to the speed in inclined surface? Okay, as you see here, if this will affect the speed, we will see now by this experiment. Okay, we know that the speed is the distance that an object travels or moves in a certain time. Okay, and as equation, speed s equals distance divided, which is t, divided by time, which is t. And we know that any moving object has kinetic energy. Yes, so now we will study the relation between the speed and the kinetic energy for the object. As in this activity, which is an experiment, we will measure the kinetic energy and the speed for an object that moves downhill like this, okay, inclined surface. Okay, so we have here angle of inclination. We will see if we change this angle of inclination, how the speed and kinetic energy will be affected. Okay, the speed and kinetic energy will increase or decrease. So here, before the experiment, let us think about this. We have here two slopes or ramp, okay, as the car moves on an inclined surface. We have figure number 1 and figure number 2. As number 1 has the angle of inclination A, which is small as you see here, and figure 2 which has the angle of inclination B, and as you see it is larger. Okay, so which car of these cars will move with high speed and more kinetic energy? Figure number 1 or figure number 2? Yes, you think that figure number 2? Yes, as if the angle of inclination increases, the speed increases and the kinetic energy. Okay, let us see. Is it right or wrong by this experiment? We have tools here: toy car, metric ruler, cardboard like this, paper cup, stopwatch, scissors, and books. As we will make the angle of inclination by using the cardboard and the books, and we will change the angle of inclination by increasing the number of books, as we start by putting 2 books. Okay, so we have small inclination angle, and by increasing the books, so we will make larger inclination angle. Okay, as we have 2 parts in this experiment, first we will know the relation between the speed and the angle of inclination, and the second part of the experiment we will see the relation between the kinetic energy and the angle of inclination, and then we will have a conclusion for this experiment. So focus here. Here is the first part of the experiment. We will put 2 books as you see, and we will put the cardboard as you see here, one end of the cardboard on the books and the other on the ground, and we will push the toy car inside the cardboard like that, and we will measure the time that the toy car reached to the other end of the cardboard. As we will find, when we have this inclination angle with that we made by 2 books, okay, the time taken by the toy car to move this distance 5 seconds, and we will repeat these steps again, but we will put another book to be 3 books. Okay, so here what happens to the angle of inclination? Yes, the angle of inclination increases. Okay, and we will push the car and we will measure the time, so the time taken now is 3 seconds. So what happens here? As when we increase the angle of inclination, the speed increases and it takes less time, shorter time to move this distance. So the angle of inclination increases, so the speed increases, and the time of travel decreases. And this is very important conclusion, that when the angle of inclination increases, so the speed increases. Okay, now we will do the second part of the experiment to know the relationship between the kinetic energy and the angle of inclination. And to measure the kinetic energy, okay, we need to add this paper cup in the other end of the cardboard as the same steps, but we have paper cup. And why? Because when the car moves inside the cardboard and hits the paper cup, it makes it moves, as the kinetic energy will transfer from the toy car to the paper cup. So the distance that the paper cup moves will be indication for the kinetic energy. Okay, because the kinetic energy transfers from the toy car to the paper cup. Okay, as we will see now. Here we will repeat the experiment as by adding 2 books and put the cardboard and make the toy car moves inside the cardboard, and it will hit the paper cup, and the paper cup will move a distance. Here we will repeat again the experiment, but we will increase the angle of inclination, and this is by putting another book. So we have 3 books, and we will repeat the same steps. We will see that the paper cup moves more distance. Okay, when we increase the angle of inclination, the paper cup moves more distance, and that means that it has more kinetic energy. Yes? So the very, very important conclusion here that when we increase the angle of inclination, so the speed increases and the kinetic energy increases as the distance that moved by the paper cup increases. So here the angle of inclination increases, the speed increases, the kinetic energy increases, and the time that taken for this will be short time as the time decreased. As you see here in this, as when the angle of inclination decreases, so the speed decreases and the kinetic energy decreases. And here the angle of inclination is larger, so here the speed increases and the kinetic energy increases. This important information, we finished lesson 2. Now we will study lesson 3 from this concept 3, unit 2. Here we have lesson 3, so don't forget to subscribe, like, and share my channel. We have activity 6, energy and collision. Remember what we said in lesson 1? Yes. When two objects bumped or crashed into each other, this is collision. As when you and your friends crash with each other, this is collision. And in this activity, we will learn the effect of collision on energy transfer. As we studied, when two objects collide with each other, amount of energy transfers between them. Yes, and there is a change happens in the energy. You remember the cricket player, when he hits the ball with the bat, what happens? Yes, there's kinetic energy transfers from the bat to the ball, make the ball change its speed and its direction, and we hear sound like pop. Okay, so what happened when the pad collides with the ball? The kinetic energy transfers to the ball, so this is the energy transfers, and part of this energy changes into another form as the sound energy that we hear when the pad collides with the ball. And we have many examples. As most of the time when there is collision, so the kinetic energy from one of these objects transfers to the other, and part of this energy changes into another form, like sound energy when we hear the sound of the collision, or light energy, and thermal energy. And this we can see in when there is collision between two cars. Okay, and it's very strong collision. So what happens? It may be fire or smoke. That means that there is thermal energy or light energy. So part of the energy change into another form, even it is sound, light, and thermal energies. Example for this: what happens if a person is running down the street without looking in front of him and hits a traffic signpost, as you see here? This man didn't look in front of him, so he collides with this traffic signpost. What happens? Yes, this post vibrates, move, and this is why, because the kinetic energy transfers from the man to the traffic signpost. Also, in the collision, we hear sound, the sound of the collision, boom. Okay, so part of this energy change into form of sound energy. So again, what are the changes that happens in the energy during collision? The kinetic energy transfers from the man's body to the traffic signpost. This causes the vibration of the traffic sign post. And a part of this kinetic energy changes into sound energy. So we hear the sound of the collision, okay? If you want another example, like here, this is a bicycle that has kinetic energy as it moves, okay? And when the cyclist collides with the bread cart, as you see here, the kinetic energy of the bicycle transfers to the cart, and the bread make them move. The cart moves and the bread falls from the cart, okay? And also there is sound happens during this collision, so the part of the kinetic energy change into sound energy, okay? Here we have activity 7, the effect of speed on collisions. Remember what we said in the first lesson? We said that the truck has more mass, has more speed, more energy, so the truck causes more damage. Yes? So here we will see the amount of kinetic energy of a moving objects depend on two things. Okay, mass of the object and the speed of the object. We know that the speed, when the speed increases, so the kinetic energy increases, because if an object has more mass, has more speed, so it has more kinetic energy, as we said. About the mass, what do you think? Which one of these vehicles has more kinetic energy, the truck or the car or the bicycle? As the bicycle can move as fast as the car or the truck? Of course, no. So here, so we can conclude that when the mass increases, the object that has more mass, so it has more kinetic energy and also more speed. So the amount of kinetic energy depends on the mass of the object and the speed. So if this object moves by high speed, so it has more kinetic energy. If this object has more mass, okay, so it has more kinetic energy, okay? So here, by increasing the speed of an object, so the kinetic energy of this object increases. When this object collides with other object, what happens? This kinetic energy transfers to the other object, and it will cause more damage. Yes, and some of this kinetic energy will transform or change into another form, like heat, energy, light, or sound, as you see here in this picture, the tree completely damaged. Thus, see here the effect of the speed on the collision. If there is a fast moving object, so it has more energy, so it exerts or applies force, more force, so this force causes big damage. And if there is a slow moving object, what happens? So it has less energy, it applies less force, so the force causes less damage, okay? And this is why driving fast is very dangerous, because when the car increases its speed, so the kinetic energy increases, and this causes more damage in the collision. Here we will see if there is collision between two objects that has different speeds, but they are in opposite direction to each other, okay, as those cars. So what happens if two cars move at different speeds in opposite direction, collide with each other? So here, this will cause more damage. And why? Because the force exerted in the accident depend on the speed of both cars. So the damage will be stronger because they move in opposite direction. Okay? So as they move in opposite direction, so the force exerted will be more and it will cause more damage. Here another case. What happens if the two cars move at different speeds in the same directions, collide with each other? So they are in the same direction, so the force exerted in the accident will be less, and it will cause less damage. With this information, we finished our lesson, so don't forget to like, share, and subscribe my channel. Thank you for watching. See you next video, inshallah, and goodbye.